I am Dr. Pavitra Bharadwaj. I am Associate Professor in the Department of Computer Science in Jesus and Mary College at the University of Delhi. So friends, we were talking about the topic of data mining, and we had discussed about the different types of data sets which are available for a data analyst, and what are the pros and cons, what are the characteristics of the data sets that one needs to look at when you are working with this. Now today's lecture we are going to talk about a very pertinent issue when you are talking about data mining, that is data quality. Now data quality, so we often this phrase is used that the quality of the analysis depends on the quality of the incumbent data. So if your data is of a certain quality, then you can expect results to be of that particular quality. But one major challenge which we see with data mining algorithm is that the algorithm is applied on a data set, then that data was actually collected for another purpose, maybe or for future, but it was not specified for what application the data was collected. So therefore data mining cannot take the advantage of the benefits of addressing the quality issues at the source, because at the source it is not even known that that particular data which is being gathered will be used for a certain data mining algorithm. So therefore this issue is commonly encountered with data analysts, that the data which they are getting is not of the reasonable quality, right? But that is not an option, because you cannot say that the data quality is a problem and therefore you cannot do the data mining. That is not the issue. The issue is that you have to, the data miner or the analyst has to focus on two aspects. First is that we detect and correct the data quality problems, and second is that we develop algorithms that will tolerate the poor data quality, right? So we have a two-prong approach. First is that we will try and detect what kind of problems are there with the quality of the data, and we will correct those. The second is that we will let the quality of the data be as it is, and instead we will create such robust algorithm that can deal with that kind of a quality flaw in the data, right? So the first step, that is when you are detecting and you are correcting the problems in the data, are known as data cleaning, right? So we are actually talking about a step called data cleaning or data pre-processing, as we say, in which we are going to make the data of a reasonable quality. We will be finding out what are the problems in the data and we will be working on that, right? So there what are the different problems that can be with the data? The data could be that there are certain missing values. That is one type of problem, or there are multiple objects which are corresponding to actually a single object, that is duplicate values, or there can be inconsistent values. So we will be looking at each of these scenarios in our discussion on data quality, right? So when we are looking at the errors which can be in the data, so there can be two types of errors that we will be looking at, right? Because data definitely will not be perfect, right? So there can be errors due to human errors, there can be some problems due to human errors, or there can be problems due to the limitations of measuring devices, or there can be errors due to the data collection process, right? So therefore three levels of problems can be there, either due to humans or due to devices or due to processes. So there can be multiple types of problems which will arise, right? And we need to identify those problems and then find a solution for those problems. So first type of problem that we look at is the measurement error problem. Measurement error deals with something like where you have a problem due to the measurement process, right? For example, one very common problem is with continuous attribute, right? The numerical difference needs to be measured, and the difference between the value and the true value is known as the error, right. So if you know the true value by some other means, by some other external source, then you can compare the two values, that is what is your reading and what is the real standard value. So you will get the error, right. So the value will be different from the true value, right. So the term data collection error will refer to errors which are due to omitting of data objects or attribute values, right, or inappropriately including a data object. Now what is data collection error? A very common example is, say for example, the study of animals of a particular species is being carried out, right. Now in this species, an object or an animal which is very similar to this species is also included, right. So now what is it? Actually the animal should not have been included, that object should not have been included in the collection process, but it has been included. So this kind of error is known as data collection error. So both data measurement error as well as collection error, they can be systematic or they can be random. But either way, whether they are systematic or random, there has to be a procedure for dealing with this kind of error. So we will consider, in this discussion we will only talk about general errors, right. There can be other types of errors also, but we will only talk about general errors. For example, keyboard errors are very common, right. So when data is being entered manually, and data entry programmers will make certain errors when they are working for long hours and they are typing the data, right. So there have to be certain programs that will detect, and because whenever there is human intervention in a process, there is a scope for errors to come in. So therefore we will need specific programs to detect those errors and also to correct such kind of errors. So when we are talking about problems with the data or the data not being clean, then there is a very commonly used term which is associated with this aspect, that is known as noise, and another aspect which is known as artifact. So what is noise? Basically noise is any random component which is coming into our data and that is causing a measurement error, right. So the value is getting distorted because of addition of spurious objects in the value, right. So it is actually if noise is added to the time series data, then its shape is completely lost, right. And the term noise is basically used in connection with data that has got spatial and temporal component. So what we are doing is that we are trying to it is very difficult to remove the noise from it. So what are we doing? We are trying to find out algorithms which are going to separate the noise from the main data, right. So the algorithms will be able to produce good results in spite of the noise which is being present, right. So these are basically distortions which come in the data because of this addition of spurious information, right. So if you look at this data, so we have the time series data in this, and in the second part of this we can see that due to the noise the time series data is actually losing a shape, and if a little more noise is added to it, then the shape of the time series data will be completely lost. So we can see that what can be the effect of noise on a particular spatiotemporal data. Then in another figure down also you can see that when noise is added to these groups of points, we can see that there are some areas where the noise is actually getting mixed up with the data points. It is getting added or it is getting inserted within the data points. So in this case it will be very difficult to eliminate the noise because the noise has become a part of the data object. So the algorithm has to work in a robust fashion so as to tackle this aspect of noise from the database. Then there is another aspect which is called as artifact, right. Now what is artifact? Artifact is also in a form it is a corruption in data, but it appears in a form that it does not look like noise. For example, if in multiple photographs you see a streak at the same point, at the same area, right. So then what is that? That is also a corruption of the data, that is also a problem with the originality and the purity of the data, but since it is appearing at the same place in multiple objects of the data set, it is said to be an artifact. So both noise and artifact need to be dealt with. Now when we are talking about data science, and when we are talking about data mining, the quality of the measurement process and the resulting data, they need to be measured. And how are we measuring the quality of the process, and how are we measuring the resultant data that we are getting? We can measure it using two basic principles, actually three basic aspects. One is known as precision, then second is known as bias, and the third is known as accuracy. So now we are looking at how we can control the data errors in the measurement process that can come in, right. So the definitions of these three aspects, that is precision, bias and accuracy, need to be understood. What is precision? Basically, it means the closeness of repeated measurements of the same quantity to one another, right. And what is bias? Bias is the variation of measurement from the quantity being measured, right. So let us consider an example here. The example is, say we have a standard laboratory weight of 1 gram, the mass is 1 gram, right, and we get a new weighing scale in the laboratory, and we need to check the precision and bias of this weighing scale. So we have this standard mass of 1 gram, and we measure it, say 5 different times on the new weighing machine that we have got, on the new scale that we have got. So we will get 5 different observations. So those different observations could be 1.015, 1.001, 0.99, you get 5 different variations in the readings that you get from a standard. So you know that the standard is 1 gram, but the values which you are getting through the new scale, you have a 5 different sets of values. So for calculating the precision, we will calculate the standard deviation of the set of values that you are getting, and for calculating the bias, we will actually find out the mean of the set of values, and we will take the difference between the value, standard value, which is being measured. So bias can be determined for objects whose measured quantity is known by means external to the current situation. So we know that the standard weight is 1 gram, but the weights which is the readings which are coming with the new scale are given differently. So therefore we can find out the mean of these values, and we can find the difference with the standard, right. Therefore we will get a bias in the value, that is how much the reading or how much the observation is deviating from the main value. And precision can be calculated using a standard formula of standard deviation, the statistical formula of standard deviation. Besides precision and bias, we also use another attribute, we also use another term basically to find out the degree of measurement error in the data, and that is accuracy. So what is accuracy? Accuracy means the closeness of measurements to the true value of the quantity being measured. That is how much accurate the measurement is vis-a-vis the actual quantity which is being measured. So accuracy will depend upon the precision and the bias, right. There is no standard formula, like we have seen there is a standard formula for precision and bias. For accuracy there is no standard formula, but we use significant digits to find out the accuracy. So if we have high precision and low bias, we say that the process is of a very high accuracy. So what are we saying in accuracy? We are trying to find out as many digits to represent the result of a measurement for calculation as justified by the precision of the data. Now for example, the best example could be that in the cloth shop you have the meter stick, right, and the meter stick has got small markings on it, right. So actually it is used for measuring 1 meter, but on it you have several millimeter markings also, right. So if you want to record the length of the data, you can only record it up to millimeter, right. So therefore the precision of such a measurement would be the accuracy of the data, and the result an analyst runs the risk of committing serious data analysis blunders in this case. Because why we are saying this? Because when the precision is not correct, then the accuracy of the data will be compromised. So the results will be compromised. So it's very important that the entire process should be a high precision and a high accuracy process that we are using. Then there is another very important aspect that we use in in connection with the quality of data, and that is known as outliers. Now outliers, basically the word outlier is also used for something like anomalous, right. That is, two types of outliers can be there. That is, the object in some sense has characteristics which are different from most of the other data objects in the data set, or the value of an attribute that are unusual with respect to the typical values of that attribute. So in both cases the particular object will be said to be an outlier. That is, it is not falling within the range of the normal data values of the object. Such objects are known as outlier objects, right. So they are also sometimes known as anomalous objects. Now these outliers, it is not like noise. It is very important that outliers and noise are treated differently, because noise is not legitimate, but outliers can be legitimate objects, and it is very important in certain cases to find out and detect the reasons for the outliers. One example of outliers could be in bank fraud detection, in credit card fraud detection. When we know that the value of a transaction for a customer has been in a particular range for a large amount of time, and suddenly the value of that attribute, that is the transaction amount, is not falling within that particular range. So that could be an alarm. So that is an outlier value, but it is a legitimate outlier, and it needs to be investigated that why this kind of an outlier value is showing in the database. So therefore it's very important that the outliers are dealt with extreme caution and carefulness by the data analyst. Then another type of problem could be of missing values, right. Now missing values can be due to multiple reasons, right. The information was not collected. For example, there are some people who, if in a survey people are asking for certain personal information, right, and like for example the age or certain things. So then people are not ready to share that information. So therefore the information is missing for a certain objects. In other cases, the information is not applicable. Like in many cases, we have forms, like in online forms we have conditions where if you fill yes for a particular field, then you have to answer more fields. If you say no, then you don't have to answer a particular set of questions in the form. So that kind of information, although it is missing, but it should not be taken into account during data analysis. Whereas the first kind of information, where the information should have been there but it was not collected due to whatever reasons, that is a different kind of scenario. So for both these scenarios, there will be different strategies which will be used, right. What are what can be the circumstances due to which the values are missing? Depending on that, we will be choosing a strategy, right. So but definitely the missing values have to be dealt with during the analysis of the data. So the first way of dealing with the missing values is to eliminate the data object or the attribute. That is, just simply remove the objects which are showing the missing value, right. So although this is this is not an advisable way of doing it, because you have partially given information for that particular object. Certain attributes are left blank, but for others the information is there. So therefore, a reliable analysis in this case will not be possible, because you are simply removing certain objects from your analysis procedure, right. Therefore, eliminating the data object should only be the last resort. It should not be a preferred strategy, because it can lead to removal of certain important data information from the analysis. The second way of dealing, or the second strategy of dealing with missing values, could be estimating the missing values, right. For example, you have a data, a continuous data which is in a smooth fashion. So you can take out, say for example, you can find out the value of that object if you know the value of the related object in time or in geographical area. Like for example, in case of weather forecasting, in case of rainfall measurement, right. If you know the rainfall, amount of rainfall at two stations, say point A and point B, but you do not know the amount of rainfall in point which lies between A and B. So in this case, what can be done? The value can be interpolated, or it can be estimated, because you have certain values, and in between that you can find out the middle value. So this can be done, when your time series data is very smooth, right, because it is very widely scattered and the missing values can be estimated. Or you can find out the missing value by filling in the mean of the values which are there, right. So this kind of estimation can help in, sufficing for the missing value. So either you can give in the interpolated value, or you can give the mean value, or you can take the value of the most commonly occurring value for that particular attribute within that data set. So you can estimate the value and you can fill that. The next strategy could be to ignore the missing value during analysis, right. That is, we can just simply overlook the objects which are having the missing value. So objects are clustered, and the similarity between pairs of data objects is to be calculated. So if both the objects of a pair have missing values, then the similarity can be calculated by only using the attribute that do not have the missing value. So we are not looking at the attribute for that particular object in which the value is missing. We are looking at the other attribute. So this strategy is actually different from the first strategy, where we were completely eliminating the object. Here we are only ignoring the attribute for which the value is missing in a correlated pair. For others we are counting it, right. So we can have different classification schemes, which can be modified to work with missing value. So we have different kinds of, the total number of attributes can be different, or the missing values can be high. So there is a lot of inaccuracy, which can come in this kind of system. So friends, we will be continuing with our discussion on the different types of problems like inconsistent data also in the following lectures. Till then, please keep watching CEC. Thank you.